Cool.
All right, great.
Okay.
Recording is on.
So join the meeting so I can share the.
If you look at this meeting on your calendar now, does it show any?
Refresh it to make sure I have the latest here. Oh wait,
Room in Sunnyvale.
Sunnyvale, yeah.
Okay. So now I'll try and see.
All right. So today I would like to talk about so kind of a change part of our config refactoring of our validation code. One of them is using Kubernetes CRD validation or Kubernetes CRD specifications for our configuration code. So the background is today we have the validation code in several different places, and then today we use the Kubernetes validating webhook to conduct a lot of validations, which namely these are happening during update and creation time of our the CRs. And then, so it poses several challenges, especially when the webhook sometimes is not enabled, or it says the port is not enabled, so the validation sometimes cannot be done. So an alternative of this is that we can, in Kubernetes starting 1.8, it starts to support the specification of the API in the CRDs inside the specification of the CR inside the CRD, so that Kubernetes API server will be able to conduct some validations for us. So the spec is an open API spec. So here I'm going through just a few benefits of what we can achieve with it. So in Kubernetes 1.15, actually, it added a few more features to the schema specification. So one particular one is it's structural schema. So the structural schema basically, from Kubernetes perspective, it defines a strict rule around how the API schema should look like. And then once it puts into the CRD definition, Kubernetes will be able to perform several functionalities or features around it. So this basically structural schema is kind of the basis for us to further do the actual validations we want to use on the CRDs. So the first thing of the structural schema, benefits of the structural schema is to use validations, to help us with validations. So like I mentioned, a lot of validation currently today we have in Python, and the validations are sometimes very basic. For example, they are specifying a DNS 1123 string pattern, so which OpenAPI schema will be able to cover that. And also sometimes it is validating the length or the maximum items of an array or something. So these requirements we can, like field specific requirements, we can specify in the OpenAPI schema. And for Kubernetes, when we have the CRDs, in the of the schema inside Kubernetes. Once we have CRs, if those do not comply, then Kubernetes will throw out errors and will not be accepting those CRs. Another benefit of this is defaulting. So we currently also in our pilot code, we do have API or configuration default, which with the help of structural schema, we can define defaults in our fields. In that way, we can assume that the resources coming into to Galley or even Pilot will have the default values if there's not any. An additional benefit of this is pruning, and which we also currently don't do and can be helpful for future. So basically, what it means is that currently, when we have our config in the CRs, if the user specify an additional field that we don't recognize, it could potentially be staying in the etcd server or API server for any time it stays there. So in the future, once we have an upgrade or some additional field added, the unknown field in the previous version can be a risk or threat to what the user may intended to have, and then pose threats to the system when the new version is introduced.
It shouldn't be an error if they have unknown fields in there.
Right now, I don't believe we have errors for this. So at least it will be it will be inside the API server and as part of the CR that's being.
I believe the pruning comes into effect especially during versioning changes, right? So every version has a different schema, so to speak, and when you are submitting a resource, you specify the API version at which you're submitting it at, right? So you can end up actually submitting it a version with these additional fields, but when you're reading it back, it can actually be read back from like an older version of the API, for example, or vice versa. There's also a literal actually like chopping off of the values thing, where if you are just putting like patching a value, patching a resource that was submitted at a higher version with additional fields, if you are submitting patching using a lower version of the API, you may end up pruning the fields that were submitted for the newer version.
Which is bad, right?
Does that make sense?
Yeah, we don't want.
Yeah, which is not necessarily good, right? Yes, that's correct. So they are actually warned about like that particular behavior by the API server folks.
Right. An additional benefit beyond that is Kubernetes starting in 1.15 can help with publishing the schema to one of its endpoint. So currently, so by default, Kubernetes publishes the Kubernetes its own resources schema into its Swagger endpoint. So with from 1.15 on, it will publish the CRD's schema although in V2 format, but it can already express many constraints there. So the usage of that is during runtime, we can have any controllers or anything like being programmed against the published schema and then do additional validations. So these are the benefits, some of the benefits we get from the CRD validation. So basically, the current state we have is we already have a tool that uses Q to generate the OpenAPI schema spec for us, which is in a separate file. So in order for us to continue continue to finish the CRD, kind of give more constraints to the CRDs, we will need to add more constraints based on the QLAN constraints. So QLAN is basically an open source tool, and it's just a constraint language, but it helps us with translating some of the constraints to the languages or to the formats that we would like to have. So example of this, the end state of what we would like this to be is we would ideally use the tool that's written in Q, and then besides each of our proto or our definitions, we will have the Q file, which specifies the constraints. So in the example here is in destination rule, we have 4 fields, just particularly for the host field. We have a pattern matching constraint. So in Q, we would specify the pattern in the Q file, and then when being generated, we would see that on the CRD, on the generated OpenAPI schema, we will see a pattern being generated, which is taken from the Q file. And also because we are not specifying this field as optional, the result of that is the host field is required in the CRD. So because our current generation of the OpenAPI schema also is already conforming to the structural schema, so we in that case we don't have to do extra work there to conform our schema to the structural schema. And then after this is generated, we'll be able to import the schema into Eastill or Eastill installer, and then during install time, we can ingest the schema into the CRDs, and the CRDs will have the schema definitions. So, like I mentioned, for the tooling part, we already have the OpenAPI schema generation, and this is will be part of our API generation pipeline. So, looking forward, we plan this to be similar, and also for testing, we I think. It should not affect any of our current end-to-end tests. So basically, it will stay the same for end-to-end test when we have the new CRDs. So an alternative we considered was for the Proto-C Gen Validate. So Proto-C Gen Validate is a tool written by Lyft, and this basically is another proto-based, proto-annotation-based constraint language. It actually provides a lot of constraints based on each individual field and primitive types of protos. However, it does not have it does not have a OpenAPI generator, so we would need to come up with our own OpenAPI generator based on that. And in addition, we currently have a lot of complex validations. For example, we do like conditional validations for our fields. which in this case, Proto-CGen validate wouldn't be able to help us specify those constraints in its own language.
Can you give an example of conditional validation, since you just mentioned that?
Example would be, I can't remember, I think in traffic policy, we validate if some fields are set, then we look at another field outside of the traffic policy and see if the field is in certain format.
Well, can you express that in OpenAPI?
I can't remember exactly.
If I remember, you can't, right?
Yeah, I can't remember it exactly, but I think that was Oz. Maybe you can.
Yeah, I think you probably can, but I think you're going to end up with a very verbose way to express it, right? You can actually have an or at the high level saying that either I have this structure or this one, right? But essentially you'll end up duplicating the whole tree on either side.
Yeah, that's what I remember too. Yeah, so it's
Yeah, so will this validation be just a subset of the current validation we have? We won't be able to express everything that we have today?
So yeah, so the CRD validation, yes, it's a subset.
Okay, so would this replace it then, or would this be alongside it?
So hopefully it will replace. So another work we plan to do, I think, which is not covered here, is we plan to generate Go code based on the queue constraints, so that we'll have the validation alongside our validation functions alongside our APIs, so we can they can be imported into Pilot code or Galley code.
So the queue constraint language is still evolving, and the author of the language is happy to help us and extend things as we need to describe more conditions. Whatever these conditions can't be represented in OpenAPI, they'll be enforced by the generated Go code that you can use. We end up with still all the constraints are expressed in one place, and they end up being enforced in a number of places or in the system.
Okay. Yeah, I just want to make sure, because Pilot really relies on some of the validations and will crash for some invalid configs. So
so there's actually three places for validation. There'll be the API server, then there's going to be Galley that implements the leftovers that can't be done by the API server. And then there's probably still validation that is very domain specific that Pilot might do in addition to all that.
Okay. Yeah.
I would actually say I just wrote a document just about this one. Validation should not be domain specific in that sense, right? So the domain is described with the API, right? So your API is the domain, and Galley is the ingester of that API. So I think it is fine to say Galley needs to understand the validation aspects of the API itself, right? And I think Q gives us the facility to do this, where we can say, here's a Q file, there's a bunch of constraints describing the shape of the things that this API can accept. And then from there, you can actually say, okay, we have the first line of defense at the API server as a JSON schema, which will probably not be rich enough to cover all the needs. And then the second line of this defense will be the validation webhook, right? Which is we can run a Go code, which is probably generated from the Q file that will actually do the validation before it even gets ingested. And the third line of defense is, okay, we validated the resource in the most automated fashion possible, but it's in isolation just by itself. Now, once Galley ingests it, you can actually look at this resource within the scope of the full graph of resources, and then do an analysis and see if that resource is valid or not, and can report, right? So we can actually report on the CRD status, for example. And I'm hoping that this would be the correct barrier, so that Pilot doesn't even need to depend on validation if we have if we go to a world where Pilot is agnostic of Kubernetes.
Yeah, so there's a kind of a decision to be made on how much validation does Pilot do on its input. in general. So if it can be used in isolation, separate from Galley, then you want Pilot to do some validation, at least, right?
Yeah. So, but the nice thing is the validation rules are like with something like QLang, it can be defined in a single place.
Yes.
And then you can generate the same consistent validation steps in either place. Either can be Galley or Pilot or something else.
Or an offline tool.
Yes, that's correct.
Yeah.
So question I had was, so you mentioned the author of Q is committed to basically implementing stuff as we need it. How strong or how confident are we in that? Because
He's the one that approached us.
okay.
And I think we're his a shipping vehicle for him.
Okay.
So yes, also in addition to that, so what Q currently can do, so just in parallel of any additional features of Q, what Q can actually do is actually it can import a Go function. So you can basically say in the Q constraint, any function that returns like Boolean can be part of your constraint, and then this can be your temporary constraint there for now. And then once Q adds more features to do the similar validations in its own language, you can replace that.
But I thought it was even walking the ASTs and from the Go code can generate some Q.
Yeah. From the Go code, yeah, you can also generate those. Yeah.
It's almost like magic.
Okay. So that's it sounds like the features that we need exist, and there are some kind of further refinements that might be coming, but that we aren't really blocked on them.
Correct. Yeah. So if somebody we want super expressive way for a constraint on list membership or that kind of stuff, then he can add that if we need it.
Okay.
In the meantime, you just put it in the code, in the handwritten code at the end of the pipeline.
Okay. And it's just another OSS project, right?
Yeah.
Yep.
Cool.
Any other questions?
So one other thing I was curious about, so right now we're generating Go code from Proto and right?
Mm-hmm.
And so if we're doing that with Q as well, does that replace our current generator? Does it augment it? How does that?
That's a different Go code.
Yeah.
So it's a separate generator that Q owns that takes Proto plus Q constraints and generates a new.
Correct. So it generates a validate function, whereas the other Go code that we generate is serialize, and deserialize.
I see. So you're saying it's orthogonal.
Yeah.
Okay.
Complementary. Yeah.
Complementary is a better way to put it. Yeah. Okay. Cool.
Yeah, I think there will be another design doc specific for that Go code generation part. So this is more on the CRD part.
Cool. So, any other questions? All right. So, do you want to touch base on the current status of the implementation? You know, where we're at. You know, or you know.
Yeah. So implementation wise, I think right now from the CRD point of view, so currently we do have this PR in to generate all the OpenAPI schema. And then the next step is we'll need to do a little bit more analysis of what we want the CRD validation to do in terms of our config, and then we can have a list of those validations, and then we will port that into Q constraints, and then add those into our API repo, and then we'll use the generator to generate the updated schema, and then once that's done, we can use Helm to help us port the schema into our YAML files, CRDs.
So is it conceivable that existing customer CRDs will not validate?
So so some of, as I mentioned, some of these features from structural schema is still in alpha stage for Kubernetes version of like 1.15 before. So in that case, we'll still use our like webhook for those validations. So we won't turn the webhook off or something. So this is mostly for. So the result of this is mostly for the users who have Kubernetes probably 1.8 plus, and then some additional features with 1.15 plus, and with the feature gate turned on. So there's some like requirements there to mostly utilize these features, but I think for now we can still have the CRDs and the CRD validation and the webhook validation in parallel.
Okay, my question was about if the user has committed CRDs into their API server and they're now invalid per these definitions, is everything going to keep working for the customer?
Yes, because do you mean like the customer will have the updated CRDs, or they will have the old CRDs?
Okay,
CRs.
if I can.
So there's corrupts, and there's a legacy CR that the customer has pushed into their API server. It fails to validate. There was no validation check for something. It was allowed in, and now we restrict it. So does it the validate? I think the validations are only on the way into the API server, and if you've already made it there, none of this stuff matters.
Yeah, so if you don't do any updates, right, like it will be validated on create and update time.
Correct.
Right. Okay. So if you don't touch those, it won't.
But they are going to touch it at some point. So or if they create a new cluster with the same config file, then it's going to start failing.
But ideally, it will be the same behavior as what we do in the webhook, because this is duplicated.
So, I think like in the event that it's not completely compatible, how do we deal with that?
I think we are conflicting a couple of things, right? So the JSON schema that we can create, I believe, and correct me if I'm wrong, is essentially going to be mostly about the shape of the proto more than the validation constraints, additional validation constraints that we can support, right? Because the structural schema, I believe, is more geared towards aligning, the proto structure, like having a baseline saying that this thing is structurally correct, right? So if the user has an invalid configuration on file, like let's assume this, right? He has it in Git, some invalid configuration, and then he tries to apply it, and it is obviously broken. So we are going to catch that, right? It is. I kind of see that scenario as more of a goodness rather than breaking an upgrade, right?
Yeah.
Because we are not already, we cannot even handle that field anyway, so we are catching a bug for them. So, but then there's the other part, which is, okay, I have this broken configuration in my API server, right? On my CRD definition doesn't have the schema now. I apply the schema, the new CRD with the schema. What happens now? Can I actually keep using that configuration, right? So is this a blocker for being able to upgrade? Is the thing that I think worth answering and making sure that it's not blocking anything. Does that make sense?
Yep. So in the upgrade story, yes. I think we need to take a look at our current upgrade story and see if this is we can change to what we have.
Okay. This is great, by the way. Thanks for tackling this one. I really wanted to get this done for such a long time. I mean, it's great to see it happening, actually.
Sounds good.
All right. Any other topics?
Today? Yes. So.
Okay. All right, folks. See you in 2 weeks.
Yeah, thanks.
Thank you. Bye.